Hi, today we're looking for the values of a and b such that this system is true. So we have a square congruence to b mode 100, and we have log a square congruent to log b mode 100. As you see, we just take log of the first congruence and we get the second one. Okay, so first we can rewrite the second congruence into 2 log by property of exponents into 2 log a log b mode 100. Since congruence is all about integers, and we have taken log here, log a and log b, so we might need to rewrite a and b into power of 10. So that means we can write a as 10 to the power of c, and b as a power of 10 to the power of maybe d. Okay, so we can rewrite our second congruence into 2 log the a become 10 to the c and b equal to, oops, sorry, this must be log b, which is 10 to the d mode 100. Okay, so the log and the 10 cancel out, so we have in the left we get 2c congruent to, also on the right part we can cancel that one, we get d mode 100. Okay, so we simplify our second congruence into no more log, so only in terms of c and d. Okay, so we need also to rewrite the first congruence into the a square become 10 to the c square congruent to b, which is 10 to the d mode 100. Okay, so that's the first one, and we can simplify a bit, so this one become 10 to the 2c congruent to 10 to the d mode 100. So we were able to rewrite our original congruence into, let me write the second one, which is 2 to the 2c congruent to d mode 100. So instead of looking for a and b, now we're looking for the c and d that satisfy this congruence. Okay, since any number is congruent to itself, and if you analyze this system, one of the solution must be 2c must be equal to d, right? So if 2c equals d, 10 to the 2c is equal to the 10 to the d, which satisfies the first congruence, and also 2c is congruent to d because they are equal. Okay, so since okay, we can find the equation, find the solution that is satisfied by this equation. So we can write the 2c equals d into c equals d divides 2. Now we can plug in this one to the value of a and b, because a and b are the values we are looking, right? So we have a equivalent to 10 to the c, which is d divides 2, d divided by 2. Then we have b being equal to 10 to the d. Okay, to make it nicer, we can because d must be divisible by 2, so we can let d equals 2n, so where n is an integer. So that means we have a equals 10 to the n, and b is equivalent to 10 to the 2n. So this is one of our solution. So we can pick any n, and like 2 or 3, and it will satisfy the original system. So besides from a being 10 to the n and b 10 to the 2n, is there any other solution that satisfy this system? Okay, working with modulo 100 is actually nice, because modulo n take only the last 2 digits of the number. So to give you example, we have 121 is congruent to 21 mode 100 because the last two number of 121 is 21. So if you're not familiar with the congruence modulo 100 or any modulo, we get 21 here because the remainder when we divide 121 with 100 is 21. Okay, so to find the value of C and D here, we might evaluate some values for small values for D. So example, so let's solve here. When D equals 0, we have 10 to the D become 1, right? So 10 to the 0 is 1. So since 1 is the value for 10 to the D, and it's asking about what is the value of C such that 10 to the 2C is having a last digit of 1, right? And this is only true when 2C is also 0, right? So there's no other values for 2C that give you last digit of 10 to the 2C being 1. Okay, so let's go D equals 1, so that's 10 to the D equals 10. And as you notice here, since we are raising 10 to the power of 2C, and we're required here that the last digit must be 10, so 2C must also be 1 to satisfy the last two digits of the number. Okay, so here 2C must also be 1, right? So next we have D equals 2, so 10 to the D equals 100. Now this is now a bit interesting because here the last two digit of 10 to the D is 2 zeros, right? So we are required to find the value for 10 to the 2C such that the last two digit is both 0. And when you raise 10 to the bigger than 2, right? So the last number is always 0. So that means here 2C must be at least 2. Okay, so if you go D equals 3, so this will give you 10 to the D equals 1000. And here, since again the last two digit is being 2 zeros, the value of 2C here must be at least 2. Because when you raise the power to 2, you get last two digit being 0. So what can we deduce from here? So that means to satisfy the first congruence, we must have D and 2C must be both greater or equal to 2 to satisfy the first congruence. Yeah, for their last two digits being equal, the exponents of 10 must be greater or equal to 2. Okay, so we haven't touched yet the second congruence. So we have here 2C congruent to D mole 100. Okay, so we're able to write our second. We have another congruence here. So we are looking for D and C such that we satisfy this new system. Okay, so what we do from here? Okay, you notice 2C is congruent to D mode 100. So that means we can deduce that 2C minus D must be equal to 100 times N, right? So you can write this one as 2C equivalent to 100N plus D. Other way to think about congruence is that since D is the last digit, right, or some kind of a last digit in a number, in the last two digit of the number, that's kind of a remainder, right, when you dividing by 100. So you can think of a number multiplied to 100 and you just add D. and that's your 2c. Okay, so we can divide by 2 here. We get c equivalent to 50n plus d over 2. Okay, in this arrangement, d must be divisible by 2, so d must be even. Okay, so that means we can let d as equivalent to 2m. So that this will give us c equals 50n plus m. So where m is an integer. So now we find the value for c, and then we just plug in this value for c back here. Okay, so let's write here. Okay, a is 10 to the c. We have a equivalent to 10. We have 50n plus m. And b is equivalent to 10 to the d, which is, the d is 2m in this case. Right, so these are our new set of solution. So n and m are any possible any integer. So we can put n and m are integer. So these are, so we have two possible solutions. Okay, so this is the first one and the first one we found. Ten to the n and b equivalent to 10 to the 2n. Okay, so n is also integer. Okay, and that's our answer in the original system.